Today we want to start Chapter 20, Section 1. The objectives are to describe how to charge an object and then explain why charging is the separation but not the creation of charges. So, Section 20-1, electrical charge. Electrostatics is simply the study of electrical charges that are collected and held in one place. So static means not moving. So we're talking about electricity that's stuck in one spot. If you drag your feet across a carpet, you're building up charge, and it's stuck on you until you touch somebody else, and then it can be discharged. But that would be electrostatics, the study of electrical charges. Now, a charged object is simply an object that exhibits electrical effects. Objects can acquire charge through friction. Like I mentioned, just rubbing your foot off the floor, so some particles rub off each other. One would become positively charged, the other negatively. And there are two other ways of charging objects. We'll talk about those tomorrow, induction and by conduction. The two types of charge are simply a positive charge and negative charge. These are arbitrarily defined. We could have called them red and blue. We could have called them up and down. We just happen to call them positive and negative. A way of getting positive charge would be if you rub glass and wool together. Well, the glass is going to be positively charged, which means the wool must be negatively charged, because when you use friction, you're separating the charge. You cannot create charge. You're only separating it. So one becomes more negative, one becomes more positive, so that overall you still have the same total charge. It's overall still neutral. To find something negatively charged, a rubber rod rubbed with silk, the rubber rod would become negatively charged, which means the silk must be positively charged. Again, all we're doing is separating charge. We're not creating charge. The general rule for charge is opposites attract. So if you have an opposite charged object, a positively charged object and a negatively charged object, they're going to attract each other. They're going to come towards each other with some electrical force. Like charges will repel. So if you have two charged particles that are both positive, that one's going to want to shoot to the right, that one's going to want to shoot to the left. The microscopic view of charge, kind of more chemistry related, we know overall atoms are neutral. And we can remove electrons to make them positively charged ions, or you can add electrons to make them negatively charged ions. But we're not just creating them. Those electrons are coming from something to make it negative, or they're leaving and going somewhere else to make the atom positively charged. So the key thing is the charges are not created, they're only separated. If you stick clothes in your dryer, it's all neutral. If you don't put in a static fabric softener, static guard, you're going to let them roll around and you're going to pull them out. They're going to stick together because of the friction. They're going to create some or separate some charge. One shirt would be negative, one positive, and they're going to want to attract. But the total charge still remains the same. So charge is conserved. Insulators are materials that don't allow charge to move easily through. Glass is a good insulator. Air is a really good insulator. That's why our new windows are double pane. You have a piece of glass which insulates, another piece of glass, and in between you have a gas, typically argon gas, but air is also an insulator. It's not quite as good. Conductors are materials that allow charges to move easily through. Typically metals are really good conductors. And plasma is simply a charged gas. Air can become a conductor if there's enough energy to rip electrons from a molecule. So if you have enough energy, if the air molecule loses an electron or gains it and becomes charged.